Hello dear friends, welcome back to my YouTube channel Chemistry Aspirant. Now in today's lecture we are going to learn about yet another important advanced theories for your chemical bonding, which is known as a molecular orbital theory. This theory was proposed in the early 19th century by F. Hunt and R.S. Mulliken to explain the behavior of molecule and the properties of the molecule that are shown after the formation of a molecule. So before studying the molecular orbital theory, we must know what is the need of the molecular orbital theory. You know that valence bond theory is related to the formation of molecule and it explains the few properties of the molecule. But we observe that all the properties of the molecules that cannot be explained by your valence bond theory. Hence, we have proposed this molecular orbital theory. So, molecular orbital theory is related to the behavior of the molecule after the formation of that molecule. Now, the question again arose in our mind, what are the properties that can be explained by using your molecular orbital theory? So, these properties are actually the bond order, then the bond length, then the stability of the molecule, and lastly the magnetic properties of the molecule. So all these properties can be explained with the help of your molecular orbital theories. So before studying the molecular orbital theory, we must know the shortcomings of the valence bond theory or the limitations of the valence bond theory. So here we observe that according to the valence bond theory, atomic orbital overlaps and they form a molecule. But after the formation of the molecule, generally the molecular orbitals are formed, which is not considered by your valence bond theory. So that was the first limitations of your valence bond theory. Then the second limit, valence bond theory unable to explain the stability of all these molecules and its ion. For example, if I considered the formation of hydrogen molecule and then the hydrogen molecule along with the positive charge, that is H2 plus ion and H2 minus ion. The third limitations of your valence bond theory. The valence bond theory does not explain the magnetic properties of the molecule. Whether molecule is going to behave as a paramagnet, diamagnet. So this is not at all considered by your valence bond theory. Hence, again if I consider the next important limitations of the valence bond theory. Valence bond theory does not explain the formation of the electron deficient molecule such as boron. In the boron atom is a electron deficient. Still, the boron molecule formation takes place. So, valence bond theory unable to explain the formation of such a electron deficient molecules also. So, these are the few shortcomings or the limitations of your valence bond theory. Hence, we proposed the molecular orbital theory. So, now let us know about what are the important points or the postulates of your molecular orbital theory. Let us start with the first postulate. Atomic orbital combine to form new orbitals in a molecule which is known as an molecular orbitals. Now here I have taken the example of formation of hydrogen molecule. Here you can observe that the 1s atomic orbital of one hydrogen atom overlap with the 1s atomic orbital of another hydrogen atom and forms the hydrogen molecule. So these two atomic orbital combines and forms the molecular orbitals in the hydrogen molecule. So this point or this postulate is actually related to the formation of molecular orbitals. So now let us know about the second postulate. In molecule, the electrons are present in the molecular orbital similar to the electrons present in the atomic orbitals in atom. The third postulate, the number of molecular orbital formed is equals to the number of atomic orbitals overlap. So here I have taken the example of hydrogen molecule. Now in case of the hydrogen molecule, the two atomic orbitals overlap, hence they form the two molecular orbital. That means the formation of molecular orbital depends upon the number of atomic orbital that are overlapping. Let us know about the fourth important postulate. The electrons present in the molecule is under the influence of a two nuclei of a combining atom. Hence, generally the molecular orbitals are polycentric in nature, which I have shown here. Generally, after the formation of your molecular orbital, the electrons that are present is under the influence of a nuclei of a two hydrogen atom in your hydrogen molecule. Hence, generally your molecular orbitals are known as an polycentric in nature. Now, let us know about the fifth postulate. Only those atomic orbital which have a proper symmetry and nearly same energy can overlap to form the molecular orbital. So here again you know that 1s atomic orbital can overlap with the 1s atomic orbital, but the 1s atomic orbital will never overlap with the 2s atomic orbital, as there is a energy gap in between them. Hence, for the formation of this molecular orbital, the atomic orbital must have the same energy or nearly same energy. Now, let us know the sixth postulate. When the two atomic orbital overlap, they form the two molecular orbital. So, out of that, one is known as an bonding molecular orbital and the second one is known as an anti-bonding molecular orbital. So, here again you can observe that after the formation of hydrogen molecule, the two atomic orbitals are formed, which is known as an bonding molecular orbital and the bonding molecular orbital that I have shown. So, now let us know about the postulate number 7. The bonding molecular orbital have lower energy and a greater stability, while the anti-bonding molecular orbital have higher energy and hence it is less stable. So, here I have shown the two energy differences between the bonding molecular orbital and anti-bonding molecular orbital. So, here you can observe that the bonding molecular orbital have lower energy than its atomic orbital, while the anti-bonding molecular orbital have the higher energy than its atomic orbital. So, here definitely if the energy is lower, stability will be more, and if the energy will be higher, stability will be less. So, this is your postulate number 7. So, let us know about the postulate number 8. We know that the axial overlapping of an atomic orbital forms the sigma bond, while the sidewise or the parallel overlapping forms the pi bond. Hence, these atomic orbitals are known as an sigma molecular orbitals or a pi molecular orbitals. Now, the postulate number 9. Generally, the bonding molecular orbitals are represented by sigma and a pi, while the anti-bonding molecular orbitals are represented by sigma star and the pi star. So, here you can observe during the formation of hydrogen molecule, the two molecular orbitals are formed. One is represented by sigma 1s, while the second molecular orbital is represented by sigma star 1s. Generally, this sigma 1s atomic orbital is lower in energy, hence it is known as a bonding molecular orbital, while that sigma star atomic orbital is higher in energy, hence it is known as an anti-bonding molecular orbital. Let us know about the 10th postulate. The electrons in the molecular orbitals, like an atomic orbitals, are filled according to the above principle, then Pauli's exclusion principle and the Hund's rule of maximum multiplicity. So, these are the 10 important postulates or the important points of your molecular orbital theory. So, in the next lecture, we will know about the linear combination of the atomic orbital for the formation of your molecular orbital. Thank you so much for watching this video. See you in my next video.